remember this question we just did in the last podcast? Remember how much it took to get all of this information down? Is there an easier way? Well, actually, yes and no. The yes meaning you're going to use your calculator. The no meaning you got to still show all of the steps. So I'm going to do the exact same question again now, but I'm going to show you all of the steps that you need to use in order to use your calculator, okay? So watch this. Give me a second. I'm going to clear this off. Now watch how to do this using your calculator. Same question, but calculator is going to help us. Check this out. This says develop the list of the potential zeros. Okay, so we know it's 12. So we know the potential zeros are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. This is going to take forever and a day. Could you imagine if you didn't have real simple factors like these guys here, 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 all the way through? What if they were this guy out here? You're going to have to go through this entire horrendous list just to find out one of the factors is 12? I don't think so. I don't like that idea at all, okay? That's going to absolutely take way too much time. So here's what I'm going to do. Watch this. I'm going to take this equation here, and I'm just going to pop it into my calculator. Watch this. This is going to freak you out. Here's the same thing popped into my calculator. There's the equation, right? X to the 4th, 2x cubed, minus 7x squared, minus x plus 12. I'm just going to do a simple graph of this real quick. Like, it's going to give me something that looks like this. I don't worry about this yet, because the actual graphical stuff we're going to do later on. But what I'm interested in is, watch this. If I hit second and hit the table, guess what I just found? Oh my gotcha. If they're really nice integers, look at that. I found out that one of my roots, p at -3, is it going to be a p at -3? Actually, no. I'm going to show you something very, very interesting right away. Okay, that's -3, -2, 1, and 2 work. Okay. So wait a second. That means x equals to 1 works, x equals to 2 works, x equals to -2 works, and x equals to -3 works. Oh my goodness. Oh my goodness. So check this out. This becomes really cool. So 1, 2, -2, and -3. X equals to 1, x equals to 2, x equals to, what was it? I can't remember. Oh no, -2 and -3. -2 and -3. Aha! So check this out. I can actually go subtract 1, x minus 1 is a factor. Subtract 2, x minus 2 is a factor. Add 2, x plus 2 is a factor. Add 3, x plus 3 is a factor. I can do it that way. Now, is that cheating? Kind of. Yeah, it's kind of cheating. So how would I go about doing this, let's say on an examination, specifically your diploma exam, where they say, show all the work? Well, guess what, folks? Real simple. You just show all the work by looking at this and saying, okay, I know that my first factor is 1. I know that's going to work. So I'm just going to go P of 1. I know that's going to equal to 0. How can they prove that you didn't do this on a scrap piece of paper somewhere? Well, if you want to, just go out to here. Just actually write it down. Go 1 to the 4th plus 2 times 1 cubed minus 7 times 1 minus 8 times 1 plus 12, and just say that that equals to 0. So you know that this guy, in fact, is a factor. You're good to go. Okay, so with that in mind, they'll say, make sure you use the synthetic division. Yeah, no problem. Okay, I'm going to put in 1, and I'm going to prove that this works. 1, 2, minus 7, minus 8, and 12. And I'm going to show that this actually works. There's 1. So 1 times 1 is 1. That works out to be 3. 3 times 1 is 3. That works out to be minus 4. Minus 4 times 1 is minus 4. That gives me my minus 12. Minus 12 times 1 gives me my minus 12. And in fact, it gives me my 0. Then this is my x position. This is my x squared. There's my x cubed. Now, I know that this guy works as well because I found it to be 0 on my calculator. Okay, so with that in mind, I'm just going to take this guy one more step. I'm going to take the 2 here and just go directly like I did in the last problem, put these values down from what I just determined, right? Minus 4 and minus 12, and I'm going to use them. There's 1. 1 times 2 is 2. That's 5. 5 times 2 is 10. That's going to give me 6. 6 times 2 is 12. That's going to give me 0. There's my 1 position, my x position, and my x squared position. Okay, so now I know my 2 factors, which I determined just by using the zeros, just like I did before, are going to be x minus 1 and x minus 2. Now, I can take this even one more step and just go out and simply PSA this, right? Which, when you're looking at PSAing this kind of thing, being that this is has a coefficient, a leading coefficient of 1, you can probably do that in your head. So you can say, oh, x minus 1, x minus 2, which we just kind of cheated by using the calculator a little bit. We know that this guy factors down to x plus 2 and x plus 3, and lo and behold, there's the same thing in a much, much, much more abbreviated way of getting the answer. I think either way, as long as you show the work and where this is going, you should get full credit.